Hello, everybody. Thank you for joining us today for a SimUG webinar titled Modernizing Grid Intelligence, how unified network models drive compliance, reliability, and DER readiness, presented by UCA and Sim Users Group. Today we have panelists from organizations from Energy Changemakers, ERCOT, PCI Tech, and Siemens. Before we begin, I'd like to go over a few housekeeping pieces for everybody. Yes, this webinar is automatically being recorded. Everybody is muted except for the presenters. A link to the recording will be sent to your email a little bit after this meeting adjourns. You can also find this recording on the Sim Users Group website in at least 24 to 48 hours under simug.org, and then click the drop down for SimUG past meetings. All attendees, again, are muted by default. Please use the chat room to interact with other attendees, and please reserve all questions for the Q&A tab up above at the top of your screen. Now I'd like to present to you Elisa Wood.
Thank you, Ryan. It's an honor to be here today with this panel of experts from ERCOT, PCI Tech, and Siemens. We're going to talk about network model management. So we're all aware that the utility world is becoming increasingly complex and that this complexity is often centered in the management of electric grid data. Data often resides in different silos within a utility or organization, across various departments, which exacerbates the complexity and sometimes the confusion. So, as I said, today we're presenting the concept of network model management, or you'll hear presenters use the term NMM as a solution. So what is network model management? Let me define it for you. Network model management breaks down the traditionally siloed approach to utility planning, protection, and operation. That problem we mentioned before of many different departments producing and using data, perhaps in different formats, not necessarily coordinating. It does so by creating a centralized master network model for transmission and distribution grids, both utility grids and ISO and RTOs. In essence, it's a unified, up-to-date source of data truth for the specialized applications each team in the organization needs to perform its work. So you can see how a model like this would come into play to improve regulatory compliance, protective relay settings, and coordination between assets, grid planning, grid operations. Let's go back and focus for a minute on the first one, regulatory compliance, because that's a big one in today's world, and there can be significant financial consequences for failing to comply. Next slide. So next slide after that, we did this one. Thank you. So this is a list of some of the regulations that address network model management from the Federal Energy Regulatory Commission, FERC, and standards created by the North American Reliability Corporation, NERC. I won't go through all of these orders and standards. You can see them on this slide here. So, we'll just talk about a few of them. I want to talk about three in particular because, well, they all address network model management in some way, but these three really come into play, and they can be fines associated with not complying with these. So we have NERC 0085, which ensures that facility ratings are used in the reliable planning and operations of bulk electric systems and determined based on technically sound principles. We have NERC 0331, which ensures models used in reliability assessments are validated and accurate, requiring periodic reviews and updates. And then last, there's of course FERC number 845, which requires more transparent and timely updates to network models. And again, these are important because there are fines associated. I'm guessing some of you out there are hearing this and nodding. These are complex rules. They require streamlined processes for compliance. And failure, as I said before, can result in fines. So our speakers will help you understand how network model management works. And perhaps most importantly, they will take you through real-world examples of its applications. So next slide, let me introduce you to our speakers. We're very happy today to have with us Eric Meyer, who is a supervisor at ERCOT for Planning Model Administration. Margaret Goodrich, who's president and founder of PCI Tech. And Dr. Yang Feng, who's a technical sales lead at Siemens Grid Software. Welcome all. It's good to see you. So let's get this discussion started. I'm going to start with you, Eric, for the first question. We're having some trouble with my camera, everybody. I'm sorry. Trying to disconnect it here so you're not seeing my keyboard. Okay, Eric, let me turn to you. So your role at ERCOT provides you with a front row seat to the challenges modern grids face, such as rapid load growth from data centers, high penetration of DERs, the complexity of aging infrastructure and extreme weather. Can you talk a little bit about what these problems look like from a grid operator's perspective? So like, what are some of the key grid management planning and modeling challenges these problems create?
Certainly. Yeah. So in the ERCOT region, we're seeing rapidly increasing demand growth. And this demand growth is growing at a rate faster than any historical load growth on the system. And we're seeing ultimately new load complexes that are reaching 6 gigawatts in scale. So by 2030, we're projected to have over 150 gigawatts of load, which comprise of your traditional, already existing base forecast. This is the load that's on the system today, along with new load that's being driven from cryptocurrency mining, data center interconnections, hydrogen, and other industrial usage in oil and gas. So, the evolution of generation, which we'll cover shortly, and this new load growth has led to a lot of challenges in figuring out how do you reliably plan and operate the grid, right? Right, we've never had to grow this fast before, and everybody wants power. They want it now. So in addition, this is also bringing in a lot of new data that we have to collect that we never had to in the past. In the past, the grid operated with the baseline assumption that we knew our transmission and distribution network, and we knew what all our generators did. Our loads were pretty small, and if any one of them tripped, it wasn't, that's an issue, and definitely we need to resolve it for the sake of reliability for the customer, but it didn't threaten grid integrity on the whole for the most part. But with these loads that are reaching massive scales, we can now have a single facility that threatens the integrity of the grid if it unexpectedly trips offline or behaves in a manner that we don't anticipate. If we can go to the next slide. So, these loads, when we look at them, they can come in anywhere from probably 12 to 18 months, typically, and even as much as 6 to 12, depending on what the load is, while we can bring generation online in 6 to 24 or 38 months, or 36 months. That's a very big difference in time scale. And then last, but we have transmission, which can still take 3 to 6 years to energize. So we have load that wants to connect to the grid. They need to be served now, while the generation is not ready and the transmission is even further behind. In addition to all this, we're seeing increased electrification of load, and we're seeing increased DER penetration. So this could be a smaller generator that's distribution connected all the way down to your rooftop solar units on everybody's house, your Tesla Powerwall, in your garage, and so forth. So this is really changing both the distribution profile and load profile that we rely on for fundamental grid planning and operation, but also the amount of data that we have to manage. When we look at having to collect data on every single DER on the system, and how accounting for that in transmission planning studies and in transmission grid operations, you're talking huge amounts of data. And, one method you could do is you could use a spreadsheet. Probably not the method I would recommend, but that's the way, a lot of things have worked. So really, in order to handle this information in a good manner and in a way that's useful, you really want some sort of centralized solution to help you handle all that data. That's not just a spreadsheet. So with all
So
these
Eric,
new,
can you tell us a little bit about that? That's exactly where I'd love to hear you go a little bit more. How can a centralized high fidelity network model help overcome these challenges you're describing? And are there advantages brought by data consistency and robust scenario planning, for example?
yeah, so with the loads, we have to take a look at a lot of data that we historically never collected on the loads capability. So instead of going from like one field on it, peak megawatt, 10 to 20, same with the DER data. So if we go to the next slide, oh, sorry, slightly different, but this is also telling the story of increased historic resource capacity additions to the grid. And we're seeing wind, solar, battery storage, all of which are much more geographically diverse. Instead of one single gas plant, we may have 4 or 5 wind and solar plants. All that exponentially increases the amount of data. Next slide. So, if you asked, Lisa, how do we manage and how do we handle that? So one of the things that we found helpful at ERCOT and is the adoption of a centralized model management and with SIM. So SIM is the Common Information Model that sort of provides the framework for how you structure your data. And then tools such as a centralized model manager, where you have one database, so to speak, that everybody can submit into that's accessed by ERCOT and the transmission companies. We can put transmission, load, generation data into. That really helps us keep a single source of truth for the entire organization. So, we've had problems with differences in topology between operations and planning. Everybody had their own different model. Things didn't match. But once we brought this all into a common source system, all of this pretty much matches now, right? Because all of these models, all of these systems for good operations and planning are being fed from the centralized model manager, which is the single source of truth. And now when you go from application A to B, it's the exact same because it's all coming from the same place. Next slide. And so, where does that leave us? That leaves us with a single source of truth that we call our network model management system at ERCOT, which is that centralized model manager that can feed data into from weekly operations models to for contingencies, one lines, maps, energy management systems, outage management systems, all the way to transmission planning models and congestion revenue right models, which are FTRs. Financial transmission rights. So, this single source of truth allows for consistency and uniformity across all of these different applications, which makes it really easy to comply with some of those NOC standards that you mentioned earlier, because we're not trying to say, why is A and B different? Well, A and B come from the exact same place, so it's guaranteed to be the same.
Very, very interesting. Thank you, Eric. That's a great overview and a great description of how this model works. Appreciate it. Okay, let's turn to Margaret. So Margaret, it's commonly claimed that NMM, Network Model Management, resolves problems of data exchange across departments. It eliminates manual efforts and it improves coordination. In practice, how are those outcomes achieved?
Okay, so, well, with an NMM, obviously, as Eric explained, you have a single repository. Now, that repository is a superset, okay, and it takes some time to get it, by the way, but you're going to have the models from planning, operations, protection, and any others, by the way. You don't have to just stop with those. You can have others. You can have GIS, you can have asset management, but the idea is you have a superset of all the models you're ever going to use, and they're aligned together so that when the departments actually make their changes, they make them to one place. And so therefore you're eliminating the manual efforts because you're only going to do it once, not 3 or 4 times. Okay. And you are improving the coordination because the departments can then see everything that's entered. They're notified of the changes automatically. If there's any coordination that is needed, they know immediately and they get together and do it. It's entered one time and used everywhere, so you don't have an error getting because somebody fat fingered this or fat fingered that. And the data exchange is automated. And so therefore you get the same data that's sent in all the exported models, but it may be a subset of what's in that superset of that one source of truth. Next slide. So if you want to see a high-level architecture of an NMM, this is one. Okay, and this I worked with EPRI to develop this one, and the reason why the boxes are blank on each side is because it doesn't matter. Okay, so the idea is on the enterprise side, on the left side, you could have protection, planning, operations, GIS, asset management, whatever it is, coming in to the model manager, and they all get aligned and hooked in and managed. And then coming out on the other side, you would export out what planning needs, for example, or what protection needs, or what operations needs, and only what is needed goes out to those consumers. So if you're doing it this way, now you've got everything in one spot. Everybody sees the same thing. If there's a problem, it's easily coordinated. They can see everything. They enter the data. They enter the changes one time as well.
It's a good graphic. Thank you. Thank you. It's very explanatory. Let me ask you a follow-up question if I can, Margaret. Let's talk a little bit about common information models, which I understand this is the foundation of network model management. Can you explain common information models to our audience and how they serve as an open, standardized foundation for network model management? I mean, how does it influence interoperability, data transparency, data integration across the utility applications?
Okay, so just everybody realize that this is normally a 3-day course, okay? And what is SIM and how do you get there, okay? So I'm going to try and get a quick introduction here. I'm going to give you a couple of slides and then, but I'm going to talk probably away from the slides a little bit to make sure you get it. So the Common Information Model, which is the SIM, is an international standard that we developed to allow data and model information to be exchanged between various systems within the utility. And it could be any of the systems in the utility. This is achieved by using a common format for all the models in the utility in terms of both syntax and semantics. That is, all the devices and objects within the utility are represented as classes with attributes and associations that can be implemented in a single repository. So one of the major elements that allows the data or model to be exchanged is the common representation of the objects in the SIM. That is, a line has one definition. I went into one utility to help them implement an NMM. They had
Oh, I think we lost Margaret. So I think Margaret went offline. So I think we'll bring Margaret back in when she can get her computer up and running again. And why don't we turn back to Eric? Eric, we know utilities and grid operators are currently using network model management, and we'd like to hear a little bit about how it's used in action. How is ERCOT employing network model management?
Yeah, so in we, on the top left corner of the diagram that you see on the screen, we have our network model management system called NIMS. This is a centralized system for operation model where transmission companies can directly submit data that represents their network. And then generation entities can submit data to ERCOT down below in the resource integration and ongoing operation system that ERCOT then puts into the network model management system. So from there, we can produce files in SIM format, XML for operation model, or that can go into our topology processor and ODMS. So this will go into our congestion revenue rights models and then our model on demand. So in essence, we have two model managers here. We have the NIMS system, which is covering operations, everything that's in the field today. And then the model on demand, which is covering everything that's in the future for a longer term transmission planning. Now, as equipment gets closer to energization, it will be brought into the network model management system, or it'll be modeled, and then then it'll go through its commissioning and energization and into control rooms and real-time operations. So this allows us to sort of manage that data flow. And because every time we build a planning model for Model on Demand, we go get the latest data from operations. So that serves as the foundation upon which all future projects can be layered upon. And so by having everything in the network model management system, each week we can bring that into energy management systems, market management systems, operator situational awareness tools, outage schedulers, etc. And every time you go from one application to the other there, it's always the same, it's always consistent. Because when we build the model, we build the files and the data necessary to populate all these applications at once, and it's all loaded at the same time. And then when we go into the planning domain, those planning models are based off that baseline operations model. So we know we always have what's in the field. And then you layer on top your future changes. And from there, that goes into your steady state model, which then flows into dynamic models, short circuit protection models, and geomagnetic disturbance models, and so forth.
Great, thank you, thank you. So let me turn.
So I'm back, Lisa.
Ah, Margaret's back. Wonderful,
Yeah.
Margaret. Can we go back to Margaret's slides? We'll pick up there again.
I do apologize, folks. Technology sometimes is bad.
It
If you go
happens.
back to that slide. Okay, so I was talking about the SIM. I'm not quite sure where I dropped off, but I want to say a key component to the SIM architecture is the notion that data exchange only happens at the interface. Therefore, each application or system can use its internal database or repository and then have import and export utilities to send and receive data from another source. So next slide. So some of the characteristics of the SIM is obviously you have data exchange or message exchange. It's expandable, which is important. If you have something, some attribute or some object that you have that is not represented in the SIM yet, you can add it to the SIM and include it in all of your systems and plug it into the single source of truth database and load in data, and you will have it going back and forth. And using the packages and the classes, the data is all represented, as I said before, in a standard structure that can be accessed by lots of different applications because now everybody knows what's going on. So, and it can be implemented as a database directly and as either a hierarchical relational object. I will say that 90% of the time it's done as a relational database. Next slide. So when you're looking at the SIM and how it's implemented, if you look at an NMM, where is SIM deployed in an NMM implementation? And you'll see here, it's on the inputs and the outputs, but then it's also the NMM itself will have a database that is in the middle, and that square box in the middle will have a database in there that has the superset that we're talking about, the super model we're talking about. And data can come in through the data imports and go out through the exports, whether it's to RTOs or to other systems. So if you look at this, the NMM, the SIM is implemented at the interface of the application. The data in the model can be sent or received using that common format and then translated to a format that the application can use. And then there's a full model repository in the center. So next slide, I think we're there. Oh, okay, I'm done then.
Okay, that was, then we got a little bit out of order, but we're fine.
Yeah, I apologize.
Yeah, not a problem at all. So Eric had actually given us some kind of a real world experience, real world knowledge of how this works at ERCOT. And now I'd like to turn to Yang because he has some examples of how utilities use network model management. Can you tell us a little bit, Yang, what are the results and what does network model management foster within their systems?
Sure, Alisa, if you can move on to the next slide, I think. Yeah, so you have saw the high-level architect diagram from Margaret, she has been rooted in this domain for more than 25 years, working with different utilities, and we partner with her all the time developing globally system like this, and you saw kind of a flavor or a sample example from Eric. But I want to highlight one of the key aspects of an NMM solution. It's never going to be the same for one utility versus the other. And if you look at the slides I'm presenting right now, this is Finland TSO, coming from under the NSOE area, and they're the only one TSO under NSOE. You'll get a different flavor as compared to what Eric has presented just now, simply because the responsibility of the utility or the ISO, TSO, the different stakeholders, engineering level, as well as even nailing down to the mindset of the tool change, the change management process, right? So how do you build up a system like this? And again, this is just one example illustrating what could be done. Doesn't necessarily tell you this is a right or wrong way to do for your utility or your customers. So if you take just a little bit your focus onto the left-hand side of the slides or the diagram right here, in the light blue ones, they are more onto kind of the asset domain, if you will, looking at the IBM Maximo asset management system, Azure GIS system. They don't necessarily host the capability of running real-time operation or long-term, dynamic simulation or power flow studies, but they host a key critical part of the components or as the source of the truth for certain part of the information. And that's why they are in as part of this equation, and they are in the picture right here. Well, starting from the bottom left, you can see the Azure GIS provides you the geo coordination, the grid connectivities tells you one transmission line goes from maybe one substation to the other, but then it doesn't really tell you what's the impedance of the line, what's the rating of the line, what is my MVA of the transformers, things like that, right? So you need to add one extra layer on top of the grid connectivity, which essentially when you are forming the grid model, that's coming from the asset management system that gets the default templates, the nameplate ratings from the asset management system, from the manufacturer, from the OEM to populate those information. And that forms kind of a grounding place for a simulation ready tool or a simulation ready model. Well, that model can be served then as a basis to get that aligned with your other systems like your EMS system for operation, your PSSE system for planning, and your PSSK, or nowadays called APA, for system coordinated protection studies, right? And you can name other tools. Again, this is not a vendor preference solution. It's supposed to be vendor agnostic, and that system can be different from one to the other, again, compared to what you have. So really just diving one further detail onto how that model can be leveraged and what are the use cases unlocked by this, right? So once you have the model built up in the NMM solution, then it can take in the SCADA system, the measurement coming from the real-time system, and then publishing, state estimation, running real-time power flow, archiving the cases, doing operational planning, and even align that model with your long-term planning study case, right? Alisa, if you can move to the next slide. And the benefits, as you can imagine, this is something that we have been touched on already, the data quality, the accuracy, the lack of the better transparency, who did what by when. And this is, really kind of a return of investment slides. But more importantly, I want to highlight the quotation from this SVP from FinGrid. They said they can calculate the full future as far as for 25 years from now. And that reminds me about a recent FERC order, I think it's 1920, that says that mandates the utility to forecast the planning model as far as 20 years. And that's a US regulation, right? So if you can map that, I know it might sound crazy to forecast as long as 20 years, considering the energy transition we are going through. but at least having that foundation, having a common information model, or having an NMM system that serves the basis for you to start from as-built model and then all the way forecast into the future, whatever what if scenario that you need to do. Next slide. This one is just a summary of standard value proposition or value chain that you would imagine company like Margaret or consultant like Margaret does, starting from the challenges, the what if, the status quo, what's going on right now, what are my major challenges, how do I tackle those going into my to-be situation, what do I want my system to look like in the future, and then bring in different vendors based on the capabilities they have, bring in the right tools, bring in the right domain know-how, and build it up ultimately for the utilities. And that's a typical value proposition, value chain that we talk about when building up a system like this. And as Margaret has rightfully highlighted, this is not going to be a 1 year or even 2 year, 3 year project, right? It's an ongoing journey usually for a customer. And for Fingrid specifically, they built up a system that was shown previously roughly in 7-year time frame. And they're not starting from everything from scratch, right? They start from operation and planning and then roll it out to maybe ASRE, roll it out to asset management. And actually, the reverse part, they start from ASRE and asset management and then align the model with operation, with planning. So that's the journey that they have embraced, and and this could look very differently from one utility to the other. And that's about what I have, Alisa.
Wonderful, thank you. Very informative. Interesting list of benefits there too. So I think we now are going to turn it over to Q&A. We're receiving quite a few questions here. If you haven't already done so, please submit your question in the Q&A panel. And I'm actually going to start with this question, which is a good one for Margaret. Margaret, we know that utilities are repositories of a great deal of valuable data that, when used effectively, can help check costs to their customers. However, managing the flow of data can be challenging, primarily since it resides in individual departments or silos without being easily visible and useful across different functions. Can you provide us with some examples of this problem?
Yes. I think we have a slide in here from the AEP project. Yes. So at AEP, when we went in there to work with them on the on an NMM, this was their architecture. They had protection, planning, EMS, outage scheduler, asset management, GIS. Each one is a silo all its own. They each had their own model. This is how they ended up getting different definitions for different devices. And they had to talk, each one of them had inputs that they had to give to the RTOs and to each other. So it was a very difficult problem. And in addition, for them, they had 6 operating companies and they had 3 different EMS systems. So there was a major issue. Kremlin is a ratings system that was developed by an independent consultant, and he was from Russia, so he named it Kremlin. So it has now been replaced, by the way. So if you go to the next slide, what they have now at AEP is what I showed earlier. So now they have the GIS coming in, the asset management coming in, and in here, when we put together the full model, we added in all of the planning, operations, and protection systems into here, along with the ratings. And we also then, I believe they bought later on a FAC8 TPS system that would help them with their ratings and putting the right ratings in here. And then you have the output. So the solution to the to the silos is to put everything into the NMM and then pull data in, push data out as needed. Does that answer the question, I think?
I think you got it. Thank you. Thank you very much, Margaret. So here's another question. This might be for Margaret or Yang. How is the first step for good implementation to NMM in CIM? Because GIS data and other repository contains much errors in data. So how is the first step for good implementation to NMM in CIM?
Margaret, you want to take the first step on that?
Okay, yeah, I can. I'll take the first hit and then you can pick up.
Sure.
Where you start with is the EMS system or the DMS system, whichever one you're actually pulling in. And that's because you've got a really solid breaker node model that you know works and that sort of thing. Then you start adding to and bringing in all the other pieces and parts. Now, there's a full discovery phase that you do when you first start this to talk about where is the data located, where's this type of data located, this type of data. So you get all of the idea, you define where everything is and what do you want to integrate as part of that discovery. And then you start with the EMS data or the DMS data or a good breaker node model, basically, that you can plug in, and then you start adding to and aligning those models. It takes that discovery phase takes probably 6 months to do because you want to get all of your use cases defined, all of the requirements defined, and get your design down as to what you're going to do when you deploy.
Good. Okay, so now the next question is about the topology processor. Is this a commercial tool or is this an in-house application development? Yang, do you want to take that?
Sure, yeah, it's actually based off a Siemens commercial software, which is called PSS-ODMS. But it does what it does. It translates a SIM model that's being exported from the NMMS system that ERCOT has, and then do topology processing and consolidate and collapse the node breaker models into a PSSE acceptable by then, the version 33 before the node breaker was introduced by PSSE, the bus branch model. So that can be aligned with the long-term planning model, which ultimately is also used by the RTOs as well as their market participants and the utilities that serves under the same area. But in short, in a nutshell, that's a commercial tool that's been developed by Siemens.
Okay, very good.
And every NMM product has a topology processor built in. However, there is a specific requirements document for topology processor that we developed when I was at ERCOT that is public. You need to make sure that whatever your topology processor is that is in the NMM product that you obtain meets all of those requirements. If it does, then you're not going to have any problem. If it doesn't, then they need to fix it.
Okay, good.
Correct.
Good. Okay, so here's another question. In the real system, there are many holders of ground truth data, e.g. distribution operators under the bulk system. Can NMM exist as a federated system that doesn't require full trust of all parties? So let's see. I would say, Margaret, do you want to take that?
Yeah, it can exist as a federated system. My question is, when you say full trust of all parties, I would want to know a little bit more information about what do you mean in that instance, but it's absolutely can exist within a federated system as one of the core integration pieces that you're going to use.
Okay, excellent. So here's a question I think I'd like to direct to Eric. Eric, what's the role of NMM for grid operators dealing with challenges created by the proliferation of distributed energy resources?
Yeah, so I think I touched on this earlier, but the main role is providing a central repository where you can house all the data and then feed all your downstream systems from that centralized repository. So instead of saying, hey, Alicia, you're going to send me a spreadsheet of all your DERs, and then Margaret's going to send me her spreadsheet, and Yang will send me his spreadsheet. You can all put your data into that centralized model manager, uh, and where we can then pull all that in a single uniform fashion. So instead of having multiple disparate systems to manage all this data and try to ingest it and push it outwards, we can just take that centralized model manager and have everyone feed into it and then push out a unified model. So network model management really makes sure that our DER data is not in its own DER database all on its own. We're bringing that in with the rest of the network data and the rest of the data needed to operate and plan the grid.
Okay, good. Here's a related question. So grid requirements standards, IEE 1547, NERC-FERC, have interpretation issues. Do we have any resources that summarize them efficiently for understanding by ISOs, DERs, and power generation owners?
That's a really good question, and I think something even we constantly have to work on at the ISOs and utilities and such, right? When a new NERC standard comes out, you sit around the table looking at the standard, trying to divine the wisdom and intent of the drafters and how it will be audited, and then how can you best meet that requirement. So I don't have a single shop to go. There are a number of companies that claim they can provide some tools to aid in understanding ISO RTO rules and so forth. I can't speak to that, but generally this is when you want to have a good compliance department that can help you understand all these things and realize what is impactful to you, what do you need to do, what do you not need to do. So most of us are generally shy away from compliance, but in this case your compliance team is your friend.
Very good. So I think this one might be for Young. How can electrical utilities overcome the enormous challenge of transforming their data from the proprietary format, whatever that format is, to CIM?
Yeah, well, great question. That's actually one of the major challenges for most of the utilities when they embrace a SIM-based solution NMM journey that has been discussed by multiple times. I think I would just summarize it maybe in 2 points. One is to embrace the vendor, first of all, has to embrace the adoption of SIM interfaces, right? And that push can come from not only the vendor inside, making their roadmap more robust and more compatible with the SIM compliance, but also coming from the utilities business consultant that when they crafting the RFPs, they can put in the specific requirements saying, oh, you need to support CGMES 2.4.15 or 3.0 or SIM 16, SIM 17 or SIM 18, whatever, right? You name it. And in that way, that becomes more of a regulatory type of a set of rule that says the vendor has to support this. And I'm seeing the trend right now that more and more utilities are putting those in. On the other hand side, and again, I hope Margaret is still here, and Ryan is definitely, you can speak on that too.
Yeah.
We as UCA and the SIM user group, the community itself has done a lot of efforts to be able to do the interoperability testing and the conformity testing on the SIM standard itself. So encouraging the vendors and having them on make them data format open and translatable into a SIM format, and also going into those interoperability tests, making sure we have a set of data or a set of documentations or the IEC rules being federated and oversaw by the entity, the regulatory body from the UCA, and then in that way, once it's proven out later on in the development phase or the implementation phase for the utilities, it becomes less of a challenge for them because it has already been done in the past. And we have seen this happening in Europe, especially when we are talking about the CGMES compliance. We went through rounds of CGMES testings and conformity tests and interoperability tests. And when we implement the solution for the European TSOs, it becomes much easier, at least in certain aspects, because most of the vendors are supporting these CGMES interfaces.
Margaret,
And
you want
David
to add
Bogan
something?
and David Bogan and myself are the co-chairs of the SIM testing committee within the UCA. We are trying to establish not only compliance testing, but interoperability testing for the SIM. The problem we have is if the vendors do not believe they have to have compliance to the SIM or interoperability with the SIM, they won't take the test. Okay, they won't participate. And we've been having that problem. So we need the utilities to say you must show that you are compliant or have participated in a compliance or an interoperability test. So once we get that in place, we will be there. Now, whether it's the SIM or some other standard, you will never get integration or interoperability if the vendors do not generate exporters and importers in and out of their proprietary data to the standardized format. This is it's a given. You got to have it. And so what we're trying to do is get the utilities, and I actually have some verbiage I've given utilities to put in their RFPs to say, you must be compliant with the SIM, and this is what compliance means, and this is what you must be able to prove and show in a proof of concept if we're going to buy your product. So once that starts happening and we start getting full testing, this will not be as near the challenge it is today. But the other thing is, if there is not an importer and exporter, the challenge is to find some integrator, such as myself, for example. There's lots of them. I can give you a whole list that will take that proprietary data and convert it to the SIM. So it is possible to do that. We've done it many times. So you can overcome this challenge.
So Margaret, you might want to take this one too. As I understand, the SIM and NMM is used to align internal models and applications. What is recommended to refresh the external model of a utility's neighbors?
Yeah, so we use the SIM as well, and we're working to do that right now at Velco, for example. We're working with New England ISO to get their models and pull them in and do some cutting, trimming, merging, that sort of thing. It's not manual work, but it is analysis and then writing up scripts, whether they're Python or some other type of script, to actually push and pull that external model and reconnect it. Now, in the SIM, you use something called boundary sets and model authority sets. And with those boundary sets and model authority sets, you can easily connect the tie lines between the external and the internal models. And that makes it much, much easier to start doing the merging and the updates to those externals on a regular basis.
Okay, excellent. Thank you. Thank you very much. Next question. Have there been ideas to use GraphDB, e.g. Neo4j, to store network models, as this can simplify topology processing and serving network models? Let's see.
I can take that. PNNL is doing some research right now on grid databases in the SIM. And Alex Anderson is who you need to contact. He is doing marvelous things with graph databases and looking at how to use them to implement the SIM and get get much more efficiencies out of it. So I would suggest that you contact him. And if you don't know how to do that, contact me and I will get you in touch with him.
Excellent. Thank you. Thank you. So next question, how is NMM used for distribution level command and control? Yang, do you want to take that?
Sure. Well, command and control, that's kind of a general concept. But we definitely have commercial software tools that's valid for and built up specifically for distribution level model management solutions. And good that you have my slides opened up on the Welco part. So if you move on actually to the next one. Yeah, so ultimately what we have done, or collectively, not saying Siemens or preferable, but collectively the community has done for Welco, or the Windows software that Welco bot has. And again, this is coming from the business consultant services coming from Margaret. The to-be progress, the to-be status for Welco is going to have a centralized model management solution that holds the data that's interfacing with operation planning, asset management, but also on the distribution side, there is a GIS interface to manage the DRs, federation and consolidation of the DRs, and maybe aggregation of those. And there's an interface, as you can see on the top bottom right, which is Symphony and Welco GIS. That's one of the ways to manage the distribution systems. Again, this is more of having a bridge of connecting the transmission system and the distribution system to assess the impact of DRs on the transmission level, but also having a model management solution. I think you all hear more and more from other vendors talking about the distribution model management solutions, which covers the distribution part of a federated and consolidated model management systems that facilitates model updates from one system to the other, which share a similar concept, but again, the tool set, the domain know-how, and the source of tools and all that may vary from case by case from the transmission level.
Okay, excellent. Very good. So a lot of questions coming in here. This is great. This is a very engaged audience. So here's one. What are examples of implementations of NMMs that don't use relational database? Do you want to continue, Yang?
Sure. So really, it depends on the implementation, right? So there is a commercial vendor offers, and there is R&D research type. Typically, when at least I'm talking on behalf of Siemens part, when we developed our solution, that was 25 years ago, right? So SQL Server relational database is a big thing by then, and still by now. But there is more innovative technology by now you can leverage. But it's kind of a vendor implementation choice, right? So it wouldn't say that you have to go either way, and SIM doesn't limit you to go either way, right? SIM is semantics and as well as the structures, right? It tells you this is the relationships, the associations, the definitions, but it doesn't tell you you have to do that in relational database. You serialize it into your XML file and then load that into whatever system that you have, right? I believe there are windows supporting even without the database. For example, they use the in-memory application to pass and assess and update the model directly, right? So even without the database, so that's all possible. So to me, it's kind of a vendor implementation choice. I know that from the past, and also there are good reasons to have relational databases. But given the time frame, I'm not going to dive into all the details. Happy to connect if you want to throw that questions and we can set up something. But having a relational relational database definitely helps you on certain parts like model tracking, the historical changes, the project and scenario modeling, the future looking, so you can keep track of what has been done and what's happening around, right? So that's really one of the benefits of having those, but it doesn't limit you to have to use the relational database based on the same concept, because it doesn't really say you have to implement your same solution inside of the database or inside of a relational database.
Okay, here's a follow-up. Are there ways to contribute or give feedback to the SIM model if you are a non-member?
That might be a question to Ryan, I think. If you're still, or I can, if you want, I can speak on behalf. I think you don't. Well, you don't have to be a member to contribute to the SIM model. First of all, the SIM community requires you. Well, maybe I was wrong, but it requires you to be a UCA member. It doesn't have to be. You don't have to be an IEC member. So UCA member. I think there is a membership that's been available for utilities or third-party consultant, independent consultant. So depending on which role you have, you can reach out to Margaret or Ryan for that specific inquiry. But on the other hand side, we as SIM community, we welcome all the contributors, all the users, and everyone who are using SIM to provide their feedback as needed to us. So there is weekly SIM user group meeting calls, or the working group meeting calls. There is also regular review, monthly review on the SIM schemas, RDFs, and the UML diagrams, enterprise architect. So all that, we definitely welcome you to join all those sessions to provide your valuable feedbacks to us. But in terms of the process, I would have to have more clarity after I talk to Ryan or Margaret on how to get you involved, whether you need to be a member or not.
Okay, great. Yeah, and you'll see a link at the end of this presentation for an upcoming event that perhaps you can get some information via that link as well.
Sure.
So this is a three-part question. Okay, I'm going to start with one, and then I'll ask after you answer two. I'll go one. I'll go to two, and then three, rather than throwing them all out at once. So, IEC 61850 conformance testing today relies heavily on validating SCL-based models. Do you foresee standardized testing or certification evolving to also cover CIM-based data exchange and its mapping with CSL? John, can I ask you to take that one?
Yeah, I think that Margaret is probably the right person to answer it, but she already left. I have to defer that question to Margaret or Tom Barry. I believe there is a plan at the UCA user group level, but myself wasn't really involved in that. So yeah,
Okay.
we can help you to address that offline.
Okay, perfect. Thank you. Okay, so this one. What role does AI play within the models and metadata, as well as what is in planning for the integration of AI? You want to take that, Young?
Yeah, sure. I can think of quite a few use cases around AI. As Margaret mentioned, PNL is pioneering with this, and there are some other utilities, as I remember, StatNet is also pioneering, depending on which context you talk about AI, right? So it could be large language model, it could be machine learnings. So there are certain use cases that's being pioneered right now by different utilities and research entities. For taking an example, right? If you want to query out again to this relational database, or whether that's or maybe MongoDB, GraphDB, to query out my substation contains what voltage level, right? Instead of typing in the query, or instead of asking, the application to tell you what's going on, you should be able to do some large language model processing to train your agent to ultimately provide you the query and then present the response to you, and then nice graphical view, and then all the diagram layout presenting you. So that could be one of the key use cases of having a machine in the loop type of interface or agentic AI implementation as part of the NMM solution, right? But right now, this is kind of pioneering phase, I would say. Quite a few utilities are interested in this, but it's really depends on their interests and the use cases that they're looking for.
Okay, that makes sense. Let's go over to Eric. Eric, what role can NMM play in alleviating backed up interconnection queues for either renewable generation or new loads?
So NMM, I guess one of the biggest challenges, we'll start with the load side, is most folks don't have a load interconnection queue per se. They have something, but they're still defining those interconnection processes and data submission and data management processes. So NMM can be a component of that where, it consumes all the data that load entities submit that are requesting interconnection. So it can sort of provide that centralized location for all the data submitted by loads, which can then be used to drive dashboards or reports or other things to inform the market. And then as far as generation interconnection, it's more of a studies issue where do you have the right policies in place? Do you have a transmission? Are you able to do your studies in time? Because a lot of that is serial studies, and they're moving to more cluster studies, and also requirements that transmission must be built before the generation can be brought online, depending on your region, although not NOCOT. So I think NMM has a role to play in keeping all your data synchronized and, managed well like it does on the load side. But a lot of the issues facing the load interconnection or generation interconnection part are not necessarily tied directly to NMM.
Okay. So I think we have time for one more question. Is there another harmonization foreseen between IEC 61850 and SIM? Yang, do you want to take that?
Sure. Yeah. So again, I personally wasn't really involved in the harmonization between IEC 61850 and the SIM standard, but we have activities going on, especially we have liaison that's coming from the 61850 working group. Tom Barry, if you were ever heard his name, he actively participates in the SIM schema reviews and making sure that SIM whatever we develop for for example SIM 18 or SIM 100 in the future, that's aligned with 61850 development as well. But in regards to the harmonization, I can refer you to Tom Barry maybe to answer that question. But we do have things going on very actively right now within the UCA working group on that.
Okay, excellent. Very good. Okay, we do need to wrap up now. I want to thank all of you. This has been a tremendously engaged audience. A lot of good questions here. Sorry we couldn't get to all of them today. I want to thank our tremendous panel of speakers, Eric Meyer from ERCOT, Margaret Goodridge of PCI Tech, and Dr. Yang Feng of Siemens Grid Software. And last, I'd like to encourage you to register for the fall 2025 SIM user group meeting. We've got the link right up here on this slide. It's called Bridging Planning and Operations, Interoperable Solutions for Rapid Grid Transformation. It's October 14th through 16th in North Carolina. So if you can make that, you can get more questions answered. And that's it for us today. Again, thank you so much, everybody, and I hope you all have a great day.